We're going to cover the next two helpers, every and some, at the same time because they're really quite similar in how they work. Between every and some, which we're going to cover right now, and the last helper we're going to discuss, which is reduce, we're starting to get into the realm of helpers where we are looking at an entire list of records or an array of something, and we're condensing down this array into a single value, like a Boolean or a number or a string. This is kind of juxtaposed against all the helpers we've looked at so far, like map and filter and find, where we look through an array and we return either a new array or a single value out of the array. So again, we're starting to get into the realm of helpers where we're condensing down everything in an array into a single value. So I know that sounds probably kind of confusing with words. Let's look at how it works in practice. So for this example, again, we're going to start off with a simple for loop, and we're going to work through some implementation, and then we're going to refactor it over to use first the every helper. So I'm going to put together an array of objects, and this time around we're going to be working with an array of computers. So inside this array of computers we have objects. Each object represents a single computer. And we'll say that we've got an Apple computer in here. And this Apple computer might have, say, like 24 gigabytes of RAM. Maybe we've got a Compaq, which is really old, and it's got just 4 gigabytes of RAM. And then maybe we've also got an Acer, which has about 16 gigabytes of RAM. We'll say 32, what the heck. So now we got 3 computers in here, and for each computer we have a name property and a RAM property, or kind of an amount of RAM. Now for this for loop that we're going to make, we're going to imagine for a second that perhaps we want to run a program on each of these computers that requires at least 16 gigabytes of RAM to be installed. Okay, so we want to find all the computers in here where we have greater than 16 gigabytes of RAM. So I'd expect that the Apple and the Acer would be able to run the computer, but the Compaq would not. So if we just wanted to find a list of the computers that could make use of this program, we could use the filter helper. That would be a great use of it. But maybe we want to take a different approach to this, and we don't want to know, maybe I don't want to know exactly which computers can run the program. Maybe I just want to know, do I have any computers that can run the program? Okay, so I want to know something like, can computers can run program. So out of all the computers I currently have in stock, tell me a Boolean value, kind of like a true or false or a yes or no. Do I have any computers that can run this program? Okay, so that's going to be the purpose of this for loop. By default, I'm going to first assign this value to true, and we'll see why in just a second. Okay, so when we start going through the for loop and working through the implementation, we'll see why I've got this true value here. I want to also have one other Boolean value. I'm going to call it only some computers can run program. And I'm going to default this one to false. And again, we'll talk about why I'm doing these defaults here when we look at the implementation of this for loop. Okay. So now, again, we want to write a for loop. Inside of this, we're going to decide whether or not any of my computers can run the program. And we're also going to decide, can all of my computers run the program as well? Let's fix up the name of this one right here, because this doesn't have a great distinction against only some. Let's say all computers. There, that makes a little bit more sense. So can all of my computers run this, or can only some? Okay. So let's do our for loop now. So we'll do I less than computers.length, increment I. And then once I'm inside the body of the for loop, I'll pick the current computer. So it'll be computers at I. And then I'll put in my business logic. So if computer.ram is less than 16 gigabytes, so if I do not have enough memory to run this particular machine, I'm going to say all computers can run program is now false. Okay, so this is why I defaulted it to true. By default, we're going to assume that all of our computers can run this program, and then only when we find a program, or excuse me, find a computer that cannot run it, will we flip that variable over to false. So that's why we defaulted this to true to start off with. Once we find one that cannot find it, we'll flip it over to false. And then at the very end, we can look at all computers can run program, and we get false because not all of them can run the program. Terrific. And then we also need to catch the other case. Let's get some new lines here. Or the other variable that we care about, I should say, which is, can only some of our computers run the program? So if any machine has less than 16, then okay, all of them cannot do it. But if at least one has greater than 16, which would be this else case right here, I would say only some computers can run program, and that's true. So now only some computers can run program. And I'm also going to put, because just to make sure all the values print up correctly, I'll put a string right here just to get the dot 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 or dash 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 right here. So now only some computers can run the program. That's true because at least the Apple and the Acer can run it. All right. So this has been a little bit tedious. I hope it seems that way, or maybe I shouldn't say hope, but I imagine it seems that way. Of putting together some logic in here, of figuring out, okay, who can run the computer, who cannot. And this really just feeds back into this running discussion that we've had about how for loops, while being fantastically flexible, take a lot of time to kind of figure out all these different edge cases. Like, okay, should I make a Boolean? And if so, what should I default it to be? Should I have defaulted this to true or false? And then once I get into the for loop, okay, I got to write out the logic in here. And let's say I'm going to take this Boolean, turn it from true to false once I find the first computer that has less than 16 gigabytes of RAM. So it took kind of a, I would argue, a non-zero amount of time to figure out the logic here. And certainly, once we have another engineer come on the scene in some number of years, they're going to look at this for loop and they're going to say, all right, they got these Booleans in here. What do they, they got to sit down and struggle, look at this code, try to figure out what's going on. So again, I'm going to make the case here that using a for loop, while very flexible, kind of leads to a little bit hard to understand code. So again, this is where our array helper is going to come into play. Let's look at a diagram, and we're first going to tackle the every helper. So let's take a look at a diagram and see what it does for us. So this is kind of a nasty looking diagram, but bear with me for just a second. We've got 3 computers in here, and I think I mixed up the numbers a little bit. Let's fix them up. So I got 24, 4, and 32. There we go. So we got 24 gigabytes of RAM, 4, and 32. So up at the top here, we've got that kind of computers array. We've got an array of objects, but we're just going to pretend that they're numbers for the purposes of this diagram. So for every element in the array, we're going to take the element, we're going to pass it into our iterator function. That iterator function will return a Boolean value. So it needs to be true or false. Once it returns true or false, we will then look at all of the values that got returned, kind of do an AND operation between all of them, and then produce a final result here of either true or false. And so in the case of looking at every single different computer and saying, does this have enough RAM to run this program, we will take a Boolean value from each element and then combine it or reduce it down to a single Boolean of yes, everything can or cannot run it. And so now that I'm looking at this diagram, I think that I accidentally flipped the squares here. So let's do like so. I apologize, but I just want to make sure the diagram does make sense. Okay, that looks better now. So the 24, I would expect, yes, this can run the program. 4, nope, it cannot, so I'm going to return false. And with 32, yes, it can run the program, so I'm going to return true. So let's figure out how to use this every helper. So I'm going to put another little bit of a divide here. And then I'm going to look at computers.every. And just like all the other helpers, we'll pass it a function that will be called with a single computer. Then out of here, we will return an element. And again, I can't stress this enough. Whenever you're using any of these helpers, you always need to make sure that you're using the return keyword whenever you're using a function. Okay, so make sure that we're always returning a value out of here. So now if every computer has greater than 16 gigabytes of RAM, then hey, what happens? So if every computer has 16 gigabytes of RAM, I would expect this to return false because they do not. And you can see over here, yep, sure enough, we get false. Not every computer has greater than 16 gigabytes of RAM. All right, so this section is running a little bit long, so let's take a quick break and then come back and do a recap on what we've done so far and then wrap up with the sum helper as well. I'll see you in just a second.